Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, we are asked to graph JKL with these vertices and its image after a 90-degree rotation about the origin. So, we have J 3, 0, K 4, 3, and L 6, 0. So 3, 0 is here for J. Oops, not J prime, just J. 4, 3 is K, and 6, 0 is L. So this is the triangle that we have. Now, we want to map this 90 degrees about the origin. How do we map things 90 degrees? What's the rule for 90 degrees? Can you remember? Did you remember? Remember that we switch A and B and make the first negative, the first coordinate. So J prime is 0, 3, and we make the 0 negative. There's no such thing as negative 0. If you think negative, positive 0, 0 is neither positive nor negative. It's right in the middle. So there is no such thing as negative 0. Okay, and then we have K prime is 3, 4, because we're switching them. And the first one becomes negative. And L prime is 0, 6, and can't make 0 negative, so it stays just the way it is. All right, J prime is at 0, 3, K prime is at negative 3, 4, and L prime is at 0, 6. Oh my, this is not tall enough. 4, 5, 6. Whoops. Silly me, I made the graph wrong. But you can see where that would have been if we had been able to go up to 6. So, and you'll see that from J to J prime is a perfect 90-degree angle. From K to K prime is a perfect 90-degree angle. And from L to L prime is a perfect 90-degree angle. So, here are our coordinates. Here is our image and our pre-image, albeit a little off the graph. Okay, thanks for doing that problem with me. Let's move on to what we have for today. Today, we are looking at dilations, another transformation, hence why it is in Chapter 4. So, our learning target for today is that you know what a dilation is, and you can perform dilations in the coordinate plane. What is a dilation? Can you perform dilations? All right, first, what is a dilation? A dilation is a transformation in which a figure is enlarged. If you are enlarging a photo, you're making it bigger, or reduced. If you're reducing something, you're making it smaller. With respect to a fixed point. That fixed point for us will be the origin. So, more information about a dilation. A transformation in which a figure is enlarged or reduced with respect to a fixed point. That fixed point is called the center of dilation. So every time you perform a dilation, you are going to have a center of dilation. For us, that is the origin. And every time you do a dilation, you will have a scale factor. We call it K, And this is the ratio of the lengths of the corresponding sides of the image and the pre-image. What this is how much you are enlarging or reducing by. Are you enlarging it to be twice the size? Are you reducing it to be half the size? How much are you dilating this figure? How much are you changing it? That's what the scale factor is. So, you, same as usual, if you'd like to take it further and you'd like more of a challenge, read this, make sure that you understand it. Another important thing that all of us need to know is if the scale factor is bigger than 1, if the scale factor were 1, it would mean that we're staying the same. Scale factor of 1, staying the same. Scale factor bigger than 1, we're getting bigger. If we're bigger than 1, if the scale factor is 2, we're getting twice as big. So that is called an enlargement because we're getting bigger. If k is between 0 and 1, k is smaller than 1, but it's still positive, like a fraction or a decimal, then we're getting smaller. If k were 1/2, we would be becoming 1/2 the size. So we'd be getting smaller, or we would have a reduction. So let's learn about the rule. There's a theme here. Each transformation we've looked at, translations, reflections, rotations, they've all had rules. Dilations also have rules. The rule for a dilation is if xy is a point in the pre-image, its image after a dilation centered at the origin, and for us, the center of dilation is the origin unless otherwise noted. And we're dilating with a scale factor of k, then p prime, or the coordinates of the image, you'll just multiply each coordinate by k. So if this is what p looks like, I take xy, I multiply each coordinate by k, and I get p prime. That's what a dilation looks like in the coordinate plane. If you're a little confused, don't worry. We're about to do an example that'll help clear things up. So, graph ABC with these vertices. We have A, 2, 1, B, 4, 1, and C, 4, -1. So let's go ahead and graph those. A is at 2, 1, B is at 4, 1, and C is at 4, -1. We want to graph ABC, which we just did, and its image after a dilation with a scale factor of 2. Remember that the rule for dilations was I multiply each coordinate by the scale factor. K is the scale factor. So for us, that scale factor is 2. So when we map from ABC to A prime, B prime, and C prime, what we're going to do is we're going to multiply each coordinate by 2. 2 times 2 is 4. 1 times 2 is 2. Ta-da! That's it. For B prime, 4 times 2 is 8, and 1 times 2 is 2. And for C prime, 4 times 2 is 8, and -1 times 2 is -2. Now, let's graph these points. 4, 2 is where A prime is. 8, 2 is where B prime is. And 8, -2 is where C prime is. Now, does the pre-image look like the image? Yes, they're the same shape. They're different sizes. They're not the exact same. They're not congruent, but they are the same shape. Now, is our image twice as big as our first shape? Well, the sides of our pre-image are 2 units long. The sides of our image are 4 units long. 2 times 2 is 4. So yeah, we did get twice as big. Awesome. So there you have it. We drew our dilation, we graphed the pre-image and its image, and we found our coordinates. So, yay! Let's check and make sure that we were right. Ooh, that's what ours looked like. And perfect, we also had the same coordinates. So yay! We were correct. Okay, let's do another example. So now, we still have, and notice that the names are exactly the same. Example 2 was dilating a figure in the coordinate plane. Example 3 is dilating a figure in the coordinate plane. But last time, example 2, our scale factor was 2. It was bigger than 1. Now, our scale factor is 1/3. It is smaller than 1. So, now, instead of getting bigger, our shape is going to get smaller. We already know that because the scale factor is less than 1. So, we have K -3, 6, L 0, 6, M 3, 3, and N -3, -3. Let's go ahead and graph those. We have -3, 6, 0, 6, 3, 3, and -3, -3. Woo, this is a big shape. Okay, so we have a quadrilateral. Now, we want to dilate this by a scale factor of 1/3. So we're going to do the exact same thing as last time. We have xy, and we're going to have kx times ky, where k is the scale factor. So for us, this will be 1/3 times x and 1/3 times y. Now, multiplying by 1/3. If I take 3 times 1/3, remember you can think of this as 3/1 times 1/3, which is 3/3, which is 1. You can think of it that way, or you can think of it as 3 times 1/3 is the same thing as 3 divided by 3. What's 3 divided by 3? 1. So you can think of multiplying by 1/3 is the same thing as dividing by 3. Okay. So K prime, L prime, M prime, and N prime. I'm going to multiply -3 by 1/3, or I can think of it as dividing by 3. So, -3 divided by 3 is -1. 6 divided by 3 is 2. 0 divided by 3 is 0. That doesn't change. 6 divided by 3 is 2. 3 divided by 3 is 1. 3 divided by 3 is 1. Negative 3 divided by 3 is negative 1. Negative 3 divided by 3 is negative 1. So, let's graph these points, k prime, l prime, m prime, and n prime. Negative 1, 2 is k prime. 0, 2 is l prime. 1, 1 is m prime. And negative 1 is n prime. We connect the dots. We get something that looks like this. Do the blue shape and the red shape have the same exact shape? Yes. Their angles are exactly the same. Their sides are different, though. And let's take a look at the sides. This side, KL, is 3 units long. K prime L prime is 1 unit long. Look at that. 3 divided by 3 gives me 1. And if we look at Kn, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. 9 divided by 3 gives me 3. So yes, we did this right. And this definitely does have a scale factor of 1/3, as we just saw when we looked at the sides. Yay! Let's check and make sure that we were correct. Ooh, our picture looked just like that, and our points looked just like this. So yay. We were right. Okay, we're gonna get into our last example for today, but first, we need to talk about negative scale factors. Ooh, what do negative scale factors do? So, in the coordinate plane, you can have scale factors that are negative numbers. When this occurs, the figure rotates 180 degrees. So when k is greater than 0, a dilation with a scale factor of negative k, just keep with me here, is the same as a composition of a dilation with a scale factor of k followed by a rotation of 180 degrees. Now, I said follow with me here because it's getting kind of confusing. But what this says is if you take a dilation with a scale factor of negative k, if we go from the blue picture to the red picture, you can also, so you can just go from xy to negative kx, negative ky. You can do that. But they want you to know it's the same thing as taking k times x, k times y, so this is a normal dilation, and then remember that if I make a and b positive, this is a rotation of 180 degrees. So what they're saying is a dilation with a negative scale factor. This is the rule, but within the rule, you have 2 transformations going on here. So when we look at the blue image, the blue pre-image and the red image, you see that not only has it gone the other way, it's gone through the origin, past the origin, but it's also rotated 180 degrees. So here, this point has gone to the other side, rotated 180 degrees. So if this didn't make sense to you, don't worry about it. If you want to be challenged, make sure that you understand this. But what you need to know is that when you dilate with a negative scale factor, it's going to flip. It's going to go through the origin and rotate 180 degrees. Now, let's jump in to an example. Our last example for the day, using a negative scale factor. So, graph triangle FGH with vertices F, G, and H, and its image after a dilation with a scale factor of -1/2. We'll come back to that. First, let's just graph our points. -4, -2 gives us F. -2, +4 gives us G. And -2, -2 gives us H. So we have a tall triangle, FGH. Now, let's come back to this scale factor of -1/2. Because it's 1/2, we know that the shape is going to get smaller. It's going to be half the size. And because of the negative, we know that this shape is going to go through the origin and flipped. So it's going to look something like this on the other side. It's going to be smaller, and it's going to be rotated 180 degrees. So let's find F prime, G prime, and H prime. What is -4 times -1/2? And remember, multiplying by -1/2 is the same thing as dividing by -2. You can think of it the same way that we did example 3. So, -4 divided by -2 is +2. -2 divided by -2 is +1. Anything divided by itself is 1. -2 divided by -2 is +1. +4 divided by -2 is -2. -2 divided by -2 is 1. -2 divided by -2 is 1. So you can also kind of see why it flips 180 degrees, because when we divide a negative by a negative, it becomes positive. And when we divide a positive by a negative, it becomes negative. So you're switching the signs of the coordinates when you divide by a negative number. Okay, let's graph these points. 2 +1 gives us F prime. 1 -2 gives us G prime. And 1 1 gives us H prime. Now, notice how point G has gone directly through the origin. Point H has gone directly through the origin, and point F has gone directly through the origin. We can see that they've gone through the origin. The line between point G and G prime crosses through the origin. And that's good, because our scale factor was negative. We can also see that this rotated. FH was on the bottom, and now H prime, F prime is on the top. And we can see that F prime, G prime, H prime is half the size of FGH, because FH is 2 units long, here it's 1 unit long, and so on. So wonderful. We were right. We kind of just checked our own answer, but let's check our answer using their example. Our picture looked like that, and our coordinates looked like that. So yes, we were right. Awesome, awesome, awesome. That is all I have for you today. That sounded like a question. That is all I have for you today. If you have any questions, please, please ask. Questions are good. Questions mean your brain is growing. Teachers love questions, so please, please, please ask me, ask your teacher, ask a friend, but get your questions answered. We are so, so happy to help you. Alrighty, these practice problems are problems you can do to practice the skills you have learned in this video. Remember to still do the homework that your teacher has assigned, but you can also do these problems if you'd like. And another thing I want to point out, when it says see example 2 and 3, see example 4, it means that these problems are just like examples 2 and 3, And these problems are just like example 4. Maybe you remember that, maybe you don't, but I would just want to remind you of that. Okay, now let's end our video with a launch. And this launch comes from Hoda Khan. And they say, life is a series of baby steps. Sometimes you don't know what the right thing is to do. Sometimes you don't know what the next thing is. All of life is a series of baby steps. So if you are, maybe you're a freshman or a sophomore and you're thinking, oh my goodness, college, I don't know, like college, after school, trade school, I don't know, what am I going to do with the rest of my life? Life is a series of baby steps. Finish freshman year. Get good grades your freshman year. Get good grades so that you can get into college if you want to do college. Don't rule out college by getting bad grades your freshman or sophomore year, but you don't need to know what you're going to do for the rest of your life your freshman or sophomore year. If you're a junior or a senior, baby steps. Look at colleges. Which ones have the degree that you want? What career do you want? Job shadow someone. Baby steps. You don't need to jump right into, I know what I'm going to do for the rest of my life right now. No. Life is a series of baby steps. So, don't stress out about the long-term things, just do the next right thing. That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.